Good morning, Tahmina Khan is here in TKMaths is fun. In today's video, which is video number 5 on sampling and estimation, we will continue to study central limit theorem, but with binomial distribution, Poisson distribution and continuous random variable, how these are connected. This is what we will see with the help of different examples. So here are the 3 QR code of P3, M1 and S2 videos. So you can scan it to watch more videos on it. So in the last video, which was video number 4, we studied central limit theorem, and we have seen that central limit theorem is helped to apply approximately normal calculation for all those sample size which has taken from the non-normal population with mean mu and variance sigma square. As long as size of the sample is larger than 30, we can apply approximately normal on the sample mean. Okay, so now the distribution we have already seen that this distribution is used to calculate the probability. So let's go straight to the question. Now we know that binomial distribution and Poisson distribution are discrete distributions. And we have seen in S1 last year that whenever we are applying normal approximation on the discrete distribution, normal approximation on the discrete distributions, we add plus minus 2 to make the continuity, right? Similarly, now when for the sample of mean of random sample, you are applying normal approximation to the discrete distribution, you add and subtract plus minus 1 over 2n. But at the same time, you know that for CLT, we take a larger sample, right? So if n will increase, what will happen to the denominator? If n will keep increasing, denominator will get very big. And 1 divided by big number will become what? This whole term will approach towards 0. Yes? So that's why it can be ignored. You cannot use continuity correction because the impact will be very, very, very small. So now let's see the question. This video may get a little longer because I want to complete all binomial, Poisson and CRV in this video. So example of binomial is in front of you. So let's see how we will solve it. So what is given to us in the question is, if you want to try out yourself by putting the video on pause, you can do that, right? So if we are seeing that we have to calculate the probability for the mean of random sample of size 100 independent observations. Now we know the moment we will see 100, it means we are talking about sample mean here, right? And we have to calculate for greater than 5. This is the question. So how do we do this? We know that the distribution for sample mean will be, when we are applying normal approximation, it will be what? It will be mean and variance. Yes? So it will be what? Right? This is what it will be. So how we will get it from the binomial distribution? From here, how we will get that? We know that mu is equals to NP, which is 12 times 0.5. Keep the calculator in your hand. You can also calculate with me. And variance was what? NPQ. Right? So it will be what? 12 into 0.4 into 0.6. This will be equals to what? 2.88. Right? So now my distribution will become, it will become 4.8 comma 2.88 over 100. So this is my distribution. Now I can use it to solve the question, and since n is large, we can apply central limit theorem. You can write down this sentence. So now I'm continuing it here. So it will be z greater than 5 minus 4.8, 2.88 over 100. So this will give me the value of z as 1.179. Now if I see here with the help of diagram, I'm talking about the right hand side area, right? And my value of z is 1.179. And I have to calculate this area. So what should I do? 1 minus left hand side probability, right? So now you can use the table and you can write down the value here, which is equals to 0.8808. So this is equals to, you can use a calculator, 0.1192. But we write the final answer in 3 significant figure, right? So 0.119, and this is your probability. So now there is one question for you to test your understanding. Answer I have given, but procedure I have not given here. So you can try it yourself and try to do it exactly the way I've explained to you over here, and I hope you will get it right. So now let's see the second example here in context of the Poisson distribution, right? So we know X be the number of telephone calls made in the evening to a counseling services modeled by a Poisson distribution. It is written to you here. So what it is like, I can say from the question I got this information that it is 6.2, right? A random sample of 45 evenings. So n is equals to 45. Since it is greater than 30, I can apply CLT. Find the probability that the mean number of calls per evening, just a second please. Okay, so we know that in Poisson distribution, mean and variance both are the same, lambda. So I can say my mu is equals to 6.2 and my variance is also equals to 6.2. This information I have from here. So now if I have to find out the probability of calls less than 5.1, it means sample mean less than 5.1. And my distribution will be what? It's better always write your distribution very clearly. So 6.2, and it is 6.2 divided by 45, right? So it will give you clear idea. So after that you will change it into z. So it will be 5.1 minus 6.2 divided by 6.2 over 45. So now you can use your calculator to get the value of z. So it will be equal to minus 2.963. 2.963. Now if I visualize it, if you're good at this mentally, you don't need to draw this, but I do it to avoid any confusion. So minus 2.963. So I have to calculate this. So we know whenever it is negative value, z value negative, we use the symmetrical concept, right? So I will use what here? 1 minus 5, 2.963. And this will give me the answer. So I need to read the table now. Probability is coming against 2.963 is 0.9985. 0.9985. So this will give me the final probability 0.0015. Okay, so this is how you will use Poisson distribution question when you have to apply sample mean with the help of CLT, right? So now let's see the last question, and here is a question for your own understanding. You have to test your understanding, so question is given here for you. Now the last question, which is connected with continuous random variable. So continuous random variable, we know when we are calculating, first part of the question is saying find the mean and variance. So this is totally in terms of what we have already done. So let's start here. 0 to 9, and I will not explain here the meaning of the question. Expectation is it's a prerequisite, so you must know this, right? So for mean, what do we do? Do you think we need to calculate the value of mean from here? We don't need to. The reason is it's a straight line, right? If you see here, this is a straight line. So mean will be exactly in the center between 0 and 9, which is equals to 4.5. So no need to calculate it. You can write straight away here. Just let me write. You can write mean of x will be 4.5. However, variance you need to calculate. So variance of x, the method we will use exactly the same thing. X square f of x dx, right? And it is minus mean square. You know that thing. So it will be equals to 0 to 9 x square 1 over 9 dx minus 4.5 square. Okay, so 1 over 9 can go out, so it will be x cube over 3, 0 to 9 minus 4.5 square, which is equals to what? 20.25. So now I will apply the values here. 1 over 9, 9 power 3 divided by 3 minus 0. So now you can pick up your calculator and give the answer in one go. No need to show further calculation here because calculator is allowed. So it is 6.75. This is your variance and this is your mean. This is part number 1. Now part 2. Part 2 is finding the probability that the mean time has to wait on a random sample of 75 occasion is less than 5 minutes. So now probability of random sample of mean less than 5. This is my question. So I need to get a distribution first of all, because that distribution I need to use here. So what it will be? Very right. We have already have that from part 1. So I can say it will be 4.5, 6.75 divided by 75. So now using this distribution, and I can write here, since n is large, the center limit theorem can be applied. Okay, so do mention this thing. Okay, so now let's calculate the probability. So z less than 5 minus 4.5, it will be 6.75 over 75. So z is what? Let me check in the calculator. 1.667. Right. So now if you want to visualize here, it is basically this. So straight away you just need to read the table. This simply means you have to read the probability against this z value, which is coming 0.9522. So in 3 significant figure, it will be 0.952. So this is how you will solve it. And one question is to test your understanding. So you can try it out. And if you will have any question, you can ask me. I'll explain it to you. Let me see. Okay, answer I have given here for you. Method I have not explained. You can use that method I have explained in the above example. And I hope you will get it right. Please press like and subscribe button and share it with your friends. Any question, write in the comments. Take care. Allah Hafiz.